Picture this, a 70-ton Airbus A320, one of the most sophisticated machines on the planet, slides right off a runway. Now it's sitting there, wheels sunk deep in the mud. The entire airport is basically grinding to a halt, the clock is ticking, and this multi-million-dollar piece of equipment is just stuck. So how in the world do you even start to fix a problem that big? And this isn't just some crazy hypothetical, you know? When a plane is disabled like this, it can shut down a major airport. We're talking a fortune in losses for the airlines and the airport for every single minute that jet sits there. The pressure to get it moved is absolutely immense. But here's the catch. One wrong move, and you could cause catastrophic damage, turning a really bad day into an unbelievable disaster. Well, it turns out there's an answer. For every single commercial aircraft out there, the manufacturer, in this case Airbus, creates this incredibly detailed, super specific document. It's called the Aircraft Recovery Manual, or ARM. And believe me, this is not just some user guide, it's the definitive playbook for what is basically a high-stakes, high-tech rescue mission. So today, we're going to walk through that very playbook. We'll look at how they survey the scene, dive into the wild physics of the lift, check out the specialized tools they use, and even uncover the global network that makes this whole thing possible. Right, so when a plane is disabled on an airfield, it has to be moved and fast. Like I said, every minute a runway is closed, the financial drain for everyone involved is just massive. The goal is to get that aircraft out of there quickly, but the number one priority above all else is to do it safely. So before a single piece of equipment even gets near that plane, a super meticulous scene survey has to happen. The ARPCM makes it crystal clear. This phase starts the second the incident is reported, way before accident investigators have even finished their work. It's all about gathering intelligence to build a perfect plan of attack. And the whole operation is broken down into these 5 distinct phases, pulled straight from the manual: survey, planning, preparation, recovery, and finally, reporting. This is not a rush job. It's a methodical, calculated process designed to eliminate every possible variable and make sure absolutely nothing is left to chance. And that initial survey, it's incredibly comprehensive. I mean, we're talking about everything from securing the site against theft to identifying any hazardous materials on board, like oxygen generators, to getting the airport blueprints to map out a recovery path. And this one is crucial: checking the weather forecast. Wind, rain, temperature, all of it can dramatically change every single decision they make from this point forward. And the level of science here gets surprisingly deep. To figure out what they're dealing with on the ground, the recovery teams use a geotechnical test called the California Bearing Ratio, or CBR. It literally measures the strength of the soil. That number tells them if the ground can support the insane weight of cranes or jacks, or if they're going to have to build a foundation first. It's basically civil engineering on the fly. Okay, so with the scene totally assessed, the next part of the challenge is just a massive physics problem. The team has to figure out the aircraft's exact weight and, even more critically, its center of gravity. See, this isn't just about lifting something heavy. It's about lifting it without the whole thing tipping over or snapping in half. A fully loaded A320 can weigh over 80,000 kilograms. That's more than 176,000 pounds. So step 1 in the prep phase is to get that number as low as humanly possible. The ARM is very clear. You make every effort to reduce the weight. The easiest way? Drain all the fuel and unload every last bag and piece of cargo. The goal is to reach what they call the net recoverable weight. And the team will seriously consider removing anything that can be safely detached. The manual has these meticulous tables listing the weight of every major component. We're talking about an engine, which can be over 2,500 kilos, the APU at 200 kilos, heck, even a single passenger door at 70 kilograms. Every single kilogram they can shed makes the big lift that much safer and easier. But, just reducing the weight is only half the battle. The real challenge is that every time you remove something, whether it's fuel from a wing tank or cargo from the front, the aircraft's center of gravity shifts. And an unstable 70-ton aircraft, well, that's an incredibly dangerous thing. And the ARM itself gives a really stark warning on this exact point. This is not a set it and forget it kind of calculation. The weight and the center of gravity have to be monitored constantly through the entire process. A sudden, unexpected shift in balance could be catastrophic, which is why every single step is planned with such insane precision. All right, once the aircraft is as light and as stable as it can possibly be, it's time for the main event, the lift.
The ARM details 3 primary ways to do this, and each one is a highly specialized tool for what seems like a totally impossible job.
First up, hydraulic jacks. And no, these are not the kind of jacks you have in your garage. The main gear jacking points on an A320 need jacks that can handle a minimum of 35,000 decanewtons. That's over 78,000 pounds of force. And remember that soil test, the California bearing ratio? This is exactly why it's so critical. You need a completely stable, prepped surface to handle that much pressure in one tiny spot.
Option number 2 is pneumatic lifting bags. You can think of these as ridiculously strong, multi-layered, high-pressure airbags. They're slid under the wings or the fuselage and then slowly inflated. This method is fantastic on soft or uneven ground because it spreads the load over a much, much wider area than a jack.
But again, the ARM is super specific here. It actually warns against using simple balloon bags because they can create what are called floating loads. Basically, the aircraft could become unstable and shift around unpredictably. So instead, teams have to use these specialized multi-cell bags that create a flat, stable lifting surface. It's a level of detail that just shows you how easily this could all go wrong.
And finally, we have the most visually dramatic method of them all: cranes. Using carefully placed straps and special fittings, one or more cranes can be used to literally hoist the aircraft up. Now, this method offers a ton of control, but it also brings in a whole new set of pretty significant risks.
And the manual gives another critical warning right here. Crane operators are absolute experts at what they do, but lifting a delicate, multi-million-dollar aircrafts is a totally different ballgame from lifting steel beams. The recovery manager has to ensure the communication is flawless and that the crane operators understand the unique dangers and the very specific load limits involved. So once the aircraft is lifted, once it's finally clear of the mud, the job still isn't over. Not by a long shot. It still has to be moved from that precarious spot all the way back to a paved surface. And a lot of the time, that means you literally have to build a road to get it there. Yeah, this is basically a full-on civil engineering project happening on an active airfield. The teams will build a temporary road. They'll excavate unstable soil, lay down a gravel foundation, cover it with steel plates or heavy timbers, all just to create a stable path with a very gentle slope so they can safely tow the aircraft home. So, you might be wondering, where does all this incredibly specialized equipment come from? The high-capacity jacks, the pneumatic bags, the custom slings and fittings. Does every airport just have a hangar full of this stuff sitting around? Well, the answer reveals this really fascinating global system of cooperation. The truth is, most airports just can't justify the cost of owning and maintaining this gear for something that might only happen once a decade, if ever. So instead, they and the airlines rely on something called the International Airlines Technical Pool, or IATP. This organization strategically places complete aircraft recovery kits at airports all over the globe. When an incident happens, the nearest kit can be flown in within hours. It ensures that no matter where in the world a plane gets stuck, the tools to rescue it are never too far away. So the next time you see a flight delay on the board, it's worth remembering this huge unseen network of expertise, planning, and technology that's always on standby. From soil science to complex physics to global logistics, rescuing a plane is a perfect example of a hidden, brilliant system that keeps our world moving. It kind of makes you wonder, doesn't it? What other invisible systems are out there quietly keeping everything on track?